Charles' law states that for a fixed amount of gas at a constant pressure, the volume of the gas will increase as its temperature increases and vice versa. The kinetic molecular theory helped explain this by describing that as a temperature increases or decreases, the volume must as well in order to allow for a constant amount of collision. So, we have our lovely hot water here, and we are going to place our balloon, which is 13 inches in diameter, in it, and we will watch as the balloon increases in size. So it's been about a minute or two, and now we'll check on the balloon and see that it has grown in size. We can see that it's already starting to shrink. The balloon, after being in the hot water for only about 2 minutes, has grown an entire inch in diameter from 13 to 14. Now, to demonstrate the other half of Charles' law, we will put this balloon in the freezer and check on it again in a bit. So it has been a few more minutes, and we're now checking on the balloon while it was in the freezer to cool down. And as we can see, it's visibly smaller, and it has decreased approximately an inch to an inch and a half in diameter. So, Gay-Lussac's law states that the pressure of a gas is directly proportional to its absolute temperature at a constant volume. And the kinetic molecular theory helps to explain this. As the pressure exerted, so the flame is going to ignite and it's going to get hot, and it's going to be at a constant volume, so it's going to push the water down, and then once the flame is extinguished, it is going to start to pull the water in, as all the molecules do, to try and balance the pressure from the outside and the inside. So we have our candle lit, and we will now place our vacuum over it and watch as first the water is decreasing, as we can see, and then once the flame is extinguished, it'll start to rise once more. So the flame has extinguished, and we can see that the water is starting to slowly rise. Oh, the water did rise as predicted. Unfortunately, the pan was bumped and the cup moved, and as such, I was not able to record it before it was disturbed and the volume was no longer. Boyle's law states that a fixed amount of gas at a constant temperature, the volume of the gas increases as the pressure of the gas decreases. So, Boyle's law states that at a constant temperature, the volume and the pressure have an inverse relationship. And the kinetic molecular theory helps to explain this because the temperature remains constant, which is the speed of the particles. So the amount of times it hits must remain constant. So to expand and allow the particles to hit the same amount of times, the pressure must decrease. And when the bottle compresses, the volume decreases, which means the pressure inside increases. So when I squeeze, you'll notice the ink comes out of the pipette. Now, the pipette should go down, but I'm not able to exert enough pressure on this bottle.